Okay. Cool. Thank you everyone for coming to Agile Web Development 2024. I'm Matthew. I'm a unit coordinator for this. It is the first time I have ever been glad that way fewer people have come to a lecture than we're supposed to, because there's supposed to be 500 people signed up to this course, and I was worrying a little bit how we're going to fit 500 people in this room. So this is a good number to start with. Hopefully we'll keep it around these numbers. Right, okay, so information about Agile Web. We've got a great team of people. I will be lecturing, and then we've got 5 fantastic lab facilitators. Lauren, Pascal, Aline, Huixin, and Tinji. A lot of them have way more experience at practical web dev than I do, so they will be a fantastic resource to turn up to in the labs for this course. And the LMS is where we will be running this course, unlike last year. Last year it was run from a separate web page, which I believe is still up. So that information is out of, if you do stumble across a separate web page, that information is out of date. I will try and get it taken down as soon as possible. There are all the usual stuff, lecture slides, which I will put up hopefully before the lecture. Well, definitely like 5 minutes before the lecture. Hopefully a little earlier than that, depending on how organized I am each week. There will be instructions for the workshops as well here, which will take place on every Friday, which we'll get to. And you can see the lecture recordings as standard. We will also use the Teams page to, is it going to load? Yep. To coordinate, and any questions that you think would benefit everyone on the course, please ask them there rather than emailing me individually. Join. Well, I really hope I'm a member. Yes. So please post any questions here that you have so everyone can benefit from them. Right. Probably should have asked, can everyone hear me? Is the mic working fine? People at the back, thumbs up? Yep, great, okay. How do I go back into present mode? Okay, cool, timetable. So, there are a lot of people taking this course this year. There were 280 last year, and I think it's gone up to 500 this year. So the number of labs have expanded drastically. The main events will be lectures every week on Wednesday 3 till 5, which will be the theory component. So these will be, well, I don't want to say really well scripted, relatively well scripted lectures with the theory behind Agile Web and everything that you need to know on the theoretical side. On Friday, there will be the workshops, which will be much less scripted, which will be me bumbling my way through trying to make an actual website and put into practice what I've been teaching you on the Wednesday. And then in the labs, there will be each of the lab facilitators, and they will help you build towards the kind of culmination of this course, which is the group project, where everyone builds a real-life working, moderately impressive piece of kit, piece of application, web application. There are office hours, technically, on Monday 10 till 12. Unless it really needs to be discussed in person, I would recommend going on Teams or dropping me an email. But in theory, I am available on Monday if you want to come and talk to me in person about something. So, what is in this course? Well, it's obviously a programming course, and it's focused on web development, and in particular, Agile software development. So not only how do you make a functioning website, web application, but also how do you go about doing it in a collaborative way with other people, such that you can produce something of a reasonably big size without tripping over yourself, tripping over each other. How do you collaborate? How do you get it so that you can set goals that you can reach in small stages rather than just magically expecting a huge project to appear fully formed in the last week? What are we going to cover? Well, we're going to cover how the web works, for starters, at a very high level. That's entirely its own lecture series, really. We're going to then cover markup languages and HTML and protocols, which is how you build the scaffolding of your website. Web styling with CSS and Bootstrap, so how you make your website look nice. Document object models, event handling, client-side scripting with JavaScript, jQuery, Ajax. This is how you make your web page reactive, how you get it to actually do stuff when you click buttons, and how to get it to load from servers, etc. We will then go on to Flask Python, the Python package Flask, which is a backend for package that helps you build your own lightweight web server on the back end. So after that, we'll cover Agile Web development and Git, which is things we've been talking about previously. And then we'll talk about architectures and object modeling. So how do you set up your back end? So to build all the relationships between the objects that you're kind of trying to model with your web application. How do you deploy your website? So how do you actually get it running on a server, up and running so other people can access it? And APIs for communicating. How's the best model to communicate between servers or between clients and servers as well. We are using all open source technology, so nothing is proprietary. You don't have to pay for anything. You will have to create a few accounts, like a Git account, but it's all free, so you should be able to do everything at home. On your own laptops, you don't need any resources provided by the university, I think. Please drop me an email if you identify anything that does. Right, okay, recommended reading. Yes, so there is a great book by Robert Sylvester, who is programming the World Wide Web. It's a little bit old now 8-9 years ago, which could probably be updated in some parts, but it's pretty good. I cannot recommend highly enough W3 Schools as a website for teaching you some of the basics of what we're going to go through in HTML, CSS, JavaScript, that sort of stuff. It has loads of fantastic examples, and it has an editor which you can just play around with in a really light and easy way to prototype your appearance of your website. And then on the back-end side of things, we, as mentioned, will be using the Flask Python package. There's a whole textbook that goes with this by Michael Grinberg, which is on the recommended reading list, I think. So the library should be available in the library. Definitely available online, I think, if you're a student. And then there's a mega tutorial, which is definitely available online for free, which you can go and look at whenever you want. And certainly the labs will borrow quite heavily from the mega tutorial. So useful resource to have bookmarked. Okay, so what everyone always wants to know at the start of any lecture series, how is it going to be assessed? So there's technically two different groups of people here, I think. There's the master's course, SITS 5505. They will have a project, a small individual project, which is due on Monday, April 15th at 5 p.m. This will be worth 10% of your final grade, and it will be to write a basic web page, no server needed on the back end, basic web page, some JavaScript, HTML, CSS, with research content. If you are an undergrad student, so you're SITS 3403, there will be a mid-semester online test run on the LMS on Friday, March 31st. Again, covering JavaScript, HTML, CSS, pretty much. This will also be 10% of your final grade. It will be held in the workshop session for that week. So you don't have to reserve any time for it because it should be blocked off on your calendar already. There'll be 10 questions, around 10 questions or less. There'll be some written answers, a little bit of coding maybe. It should take about 60 minutes. Okay, so the group project is the big one, which is worth 40% of the final grade. That is due on Sunday, May 19th. Last year, you had a bit of flexibility between groups of 2 and 4. This year, I'm afraid with numbers, I'm going to have to make it that you do need to do it in groups of 4. Apologies for that. Of course, it's getting a little bit bigger. Apparently it took 2 weeks to mark last year. So with an extra 200 students, I'm not looking forward to how many it's going to take this year. So yeah, groups of 4, I'm afraid. And we are going this year, everyone is going to build a request board application, which is incredibly vague, and that is deliberately vague because you can do almost anything with it, as long as people can, you're going to build an application where people can make requests and people can answer requests. And you log on as users, but apart from that kind of brief, you can do pretty much anything you want. So it might be, users post puzzles as requests, and then other users can answer the requests by solving the puzzles, for example, and get ranking points. You could make an actual request board for your local community, people who want to borrow tools, and people can answer and say, yes, I have these, or no, they don't. Very, very broad. You can make an RPG one, and with RPG-style quests for your favorite computer game. Very open to it, to whatever. Yes, question? March 31st is a Sunday this year. It is. Oh. Okay, I definitely mean Friday, whichever Friday that is. Is that on the... That is an excellent point. Apologies, Friday 29th. Thank you. I will make a note of that. Friday 29th. Yes. Was it a Sunday last year? Was that me? Yeah. It was a Friday last year. Okay. Okay, sorry. Apologies. If that's in the unit outline as well, I deeply apologize. 29th. Yes. Okay. So, group project. And then there'll be a final written exam that we were 50% of mark that will happen in exam week. All the usual stuff. Please ensure you've consulted the unit outline for things like what happens on unsatisfactory progress, penalties for late assessments, plagiarism and AI tools. We absolutely do encourage you to use AI tools like generative code assistants like ChatGPT or other ones in the group project, as long as you cite properly where your code is coming from and you highlight in the source code which bits are ChatGPT generated and which bits are not, which bits are entirely your own. And obviously academic misconduct, plagiarism, and the policy for adjusting marks at the end of it. Yes? So the details will be shared in round about end of week 2, middle of week 3. And then group sign up will be probably at the start of week 4, I imagine, where you sign up for your groups. Yes, so we will request that you ask the technology, that you use the technologies that we cover in this course. So we will want a Flask backend, JavaScript, jQuery. I am yet undecided whether I'm going to insist on everyone using the Bootstrap CSS framework or whether people can use other frameworks, but that will be made clear. But yes, quite prescriptive on the technologies, I'm afraid. The library? In what way? Yes, I think so. There will be full details published long before you get going on actually hacking away at it. Okay, so yes, the group project is traditionally the bit that everyone really, really likes. no pressure, guys. But traditionally, that's the best fit for everyone. It's your first chance to build something that is really it's got all the features that real-life websites and web applications will have. And by the end of this, you should be able to go away and think even something massive like, Facebook, you should go away and think, yes, if I had 5 years, I would know how to go away and build that. Obviously, you're on your own, so you don't have a resource to put in it, but you should be able to understand how these applications are put together. And yes, completely unsolicited email, actually just a couple of days ago. 2 years ago, Wordle was sweeping the globe. So the group project that year was to create a word-based game that users could log on to and submit high scores and things like that. And we just got this email from someone who said that they created a Minecraft version of Wordle for crafting recipes that refreshed every day, new puzzle every day. And they put it up online at the end of the group project and went away and forgot about it. And 2-3 months ago, a YouTuber picked it up. And they've now got 1 million players who are playing this game. So, as I say, the group projects really can be an amazing opportunity to build something realistic and to have something great to put on your portfolio if you're looking to going into web dev jobs at the end of the course. And yes, you have a lot of freedom. The brief was to create a word game. They came up with this, which was completely acceptable within the brief, Wordle-like game, and they got great marks for this. So yes, take request board very loosely. It's really up to you and your imagination about what you want to do. If you do want to start discussing with friends or people in groups about ideas now, that's absolutely fine as well. As I say, group signups won't be until start of week 4, I guess. Okay, so that is all the admin stuff that I have. Does anyone else have any questions about course admin? Yes.
In the labs, we enrolled into 2 slots for the labs. One of the labs was some of the lab slots are 1 day.
Yes, so for some reason this year, we've been really unlucky this course this year in that we are hitting a lot of bank holidays. I hear there's also a newspaper day where everyone goes out and sells newspapers. I really don't understand that. I'm new to UWA, so I'm going to take teaching ops at their word that happens. So a lot of the labs have been cancelled and rearranged to other days. So the 1-day only labs, as I understand it, are the ones that have been rearranged to new times, just for that 1 week. And they should be showing up in your timetables. Yeah, there's still a question, which isn't a good sign, but yeah, go for it.
I'm not aware. I don't think that this unit.
Yep.
Can we just show up to any of the labs?
Okay, that's an excellent question. So the lab sessions, everyone signed up to a specific one. That I would really strongly encourage people to turn up to the one that you're signed up on, because simply for balancing numbers. Because there will be one facilitator at the lab sessions, and if 150 people turn up to that one lab session, they are in trouble. Having said that, you should be able to message your facilitator on chat, on the Teams chat, and if for a particular 1 week you can't make it, you can message a facilitator and ask, can I turn up to this session? And if they give you permission, then that's absolutely fine. Does that make sense? Okay, cool. Yes? I'm really sorry, you're going to have to speak up. Yes, so you will have yes, everyone can choose their own group of 4. There will also be an option to sign up saying, please assign me to a group. And there's that option too. Yes, it will be very difficult, just like in real life, when you're assigned to a web dev team, to a development team, it will be incredibly difficult to back out of your group once you have picked it. So just make sure that when the sign up time does come, you're putting down the right 4 people. Cool. Okay, one last question, yep. Yep. Oh God, is it? Ah, dear. Is it Good Friday? Yes. Yes, it is. Okay, the test will not be on that Friday.
Next Friday?
Let me, before I put my foot in my mouth any further, let me get back to you on I will be an announcement on LMS. I will announce it in the workshop this Friday about when the test will be. Yes. That is a great start. Anyway, okay, thank you for pointing that out as well. That is very useful. Okay, great. So, I guess let's get started. So, we're going to go a long, long way back in time to when the internet didn't exist. And we're going to walk through, basically in this first lecture, we're going to walk through the history of the internet and how it came to be, and some of the applications that were built on it, and a very high-level overview of the protocols that are used. Cool. Who, hands up, who loves XKCD? Who reads XKCD? Whoa. Whoa, that is so few. Okay, cool. Okay, it's a webcomic series that I really like. There'll be comics from it throughout. Yes, God, I must be getting old. Okay, right. What is a computer network? So, hopefully, as all third years or masters or 4th years or master students, you're probably across this. But a computer network is a structure that links devices together for the purpose of communication. And the obvious way to model these things is a graph, mathematically, where the computers are the nodes of the graph, and the communication links between them are the edges. And using this, if your graph is fully connected, then you can communicate from, hopefully, if all the nodes of the network cooperate, you can use this network to send information from one node to any other node in the graph that there's a connection to. Okay, so what did networks look like before the internet came along? Networking computers started being built. The first computers were started being built in the early 1950s. The networks came along not long after. Within 5 years of the first computers being built, people quickly realized that, oh, wouldn't it be great if computers could talk to each other? And we could actually transfer data between them. And as with many computer science technologies, the Department of Defense in the US was one of the main funders for these things. And they created the Advanced Research Projects Agency, ARPA, and that was very much interested in communication networks, so communicating between different computers, sharing programs, and accessing computers remotely. At this time, if you wanted to use a computer, you had to make a physical pilgrimage to one of the 6 computers in the US. And you actually had to go and travel there, and you had to take days and days writing your program very laboriously. They wanted to be able to access any computer from any other computer in the US. And in particular, they were motivated by military concerns, and they wanted that this network would continue to function. If one computer dropped out of this network, then all the rest of the network would remain robust and intact. So they wanted redundancy in the network. And as a result of this research project, ARPANET was created, and this linked about half a dozen to a dozen computer labs and universities around the country. And actually a lot of the, well, I'm going to say grunt work, but not the grunt work. I mean, everything was not grunt work at this time because this was super new, cutting edge stuff. A lot of the work was done by PhD students and grad students in the universities. So they really played a huge part in getting it up and running. Having said that, it didn't quite live up to the grandiose dreams of exactly what they wanted. I mean, it's a bit like in the 1960s, famous computer science professor at MIT said, got people together and said, got some grad students together for the summer project and said that they were going to solve computer vision and to recognize arbitrary objects and images, and they said it would take about 2 months. Obviously that didn't happen, and we're only just starting to crack that now, 60 years later, but it was very similar thing that they thought it would be really easy, and in practice, having a reliable, robust network that you could transfer arbitrary stuff over was quite hard. So ARPANET was mostly text-based email that you could send, and building a new physical link between different computers was really time-consuming and expensive. But it was still incredibly useful. I mean, the fact that you could send a message instantly, a text-based message instantly without actually having to phone without having to phone someone was pretty revolutionary even then. Yeah.
Did they build this physical level name or use the existing telephone network?
So they use the existing telephone network. Yeah. So people saw this network, and they were like, yeah, we would really like to join. But this was a defense project, and they were very wary of people wanting to join their network. So other universities started creating their own networks. And there were various ones in the late 70s and early 80s, BitNet, because it's time network, and again, electronic mail and file transfer, and for example, CSSNet, which again just did email. But they started proliferating. So there were lots of these different networks. They were not connected, so they're disjoint. So you couldn't send email from one to the other, but you could only send email within an individual network. Well, what happened? Well, a new network came along called NSFNet, which was in 1986 by the National Science Foundation. It was originally for non-defense universities and research labs, and just connected 5 big centers where they had supercomputers at the time. But it quickly gained popularity. I mean, there was a network effect, right? I mean, maybe that's, yes, network effect, yeah. Where like the more people joined it, the more value it had because the more people you could communicate with. So there was quick incentives to get very, very, very big, as indeed same effects happen in social networks nowadays. Once you reach a critical size as a social network, your value goes up because you can communicate with more and more people. And by late 80s, it was starting to be used by companies as well, not just universities or research labs, but companies to send mail, and big internet service providers started popping up. And by 1990, ARPANET was not as useful. Everyone was looking at NSFNet and going, wow, so many people are on that. Why are we on ARPANET that we can only talk to people who are funded by the defense? Eventually, all the other networks that started existing started linking up to NSFNet. So they started adding communication links into NSFNet so they could connect everyone. And then by 1992, there were 1 million computers, which seems, I mean, now there's probably tens of millions of computers in Perth alone, but by that time, that was pretty much most of the computers in the world were connected to NSFNet, and so there was now just one global network, which came to be known as the internet. What is the internet today? Well, it's still a network of interconnected networks. Different people in the internet own different portions of the underlying physical infrastructure. What happens is that it's actually evolved into a hierarchical network. So there's a high-level network of very, very high-capacity links, which are known as backbone links, which carry an awful lot of the traffic. So linking, Australia to mainland Asia, or Asia to Europe, or Europe to the States, and there's maybe, I actually don't know how many links cross the Atlantic or the Pacific, but on the order of 5 to 10 big backbone links that cross it. And then from that big backbone, there's lots of smaller networks that are owned by local providers that connect everything up. Yes, and the local providers can be companies, universities, or nations. It certainly achieved ARPA's original goal, that if part of its infrastructure is destroyed, data can flow through the remaining network. It seems almost ludicrous now, but imagine someone drops a brick on your laptop. The rest of the internet doesn't topple over, right? But even if entire countries drop offline, big chunks of the internet drop offline, in theory, it all still works. I have said in practice, because for various reasons there are trends towards centralization points in the internet in the last 10, 20 years, and particularly in routing, and if it is possible to disrupt large parts of the internet from a single point, if you are in charge of enough of the routing tables, for example. If you're in charge of routing for a large country, for example, you can suck in everyone else's traffic, usually by accident. But yes, in principle, it is robust. And by the early 2000s, it had become the biggest piece of computer infrastructure in the world by far, and in fact, pretty much the biggest piece of infrastructure, full stop, in terms of the sheer amount of effort and even just physical material that went into it. And yes, today there's tens of billions of devices attached to the internet. Computers, smartphones are the obvious ones, and then it gets progressively more ridiculous what people are connecting to the internet today. And I was trying to find the most ridiculous thing that people have connected to the internet, and I came up with this, which is the Hydrate Spark Pro, which is an internet-connected water bottle that tells you how much water you've been drinking, in case you drink water on autopilot. Yes. I'm not sure of the utility of this, whether it'll still be around. I may have to revamp these slides in a couple of years when this product has dropped off the marketplace. I really hope I do have to drop this from the slides. All of these devices on the internet are connected via a wide variety of links. So remember the graph that we showed right on the first slide? The links are not all made up of one sort of link. There are many, many different types. You can have copper, fiber optic, satellite, phone links. The idea is that the internet is entirely agnostic as to what the physical infrastructure is that is underlying your network. It really doesn't care. In theory, you could run an internet link of carrier pigeons that passed, handwritten notes from one computer to another and had people typing it in. It would be, the latency on that link would be unbelievably slow, and I don't think you'd get much uptake. But in theory, the internet would run on it. So yes, really is agnostic to the sort of links that you have. So, okay, so that's pretty much gets us up to where the internet is today, and a whistle-stop tour. So the next question is, how does the internet work? How does it actually function over those links? And the glue that holds it all together is communication protocols. So all that gets transmitted over those links is a sequence of bits. It's digital data. Okay. Yes. So the carrier pigeon analogy is perhaps, okay, you'd have to be sending digital data that you could type into the computer at the other end. Apologies, not handwritten notes. Well, handwritten digital data. So all the links can send is ones and zeros, right? And from that, you have got to, all the computers in the network have got to share a common understanding of what those zeros and ones mean to them. And they should have the same understanding. And communication is only possible because they have the same understanding. And the understanding, this notion of understanding what these bits mean is known as a protocol. And in the internet, it's very high, you have very high level functionality. You can send cat gifts to your friends, but underneath that, with a single click of a button, the technology underlying that is that there are many, maybe 40 or 50 different protocols that go on underneath that one action that are responsible for different parts of transmitting the information and ensuring that information gets from one computer in the network to the other, from your phone to your friend's phone. So, what sort of protocols are there down there? The first one is the IP protocol, which dictates how you name nodes in the network. If you want to, you're saying you've got your friend's phone number, it needs to translate that from your friend's phone into a physical, into an actual name, a unique name on the internet that you can send it to. And it should identify it. It should be used to be able to distinguish your device from every other device on the internet. So obviously you need a way of agreeing a consistent format for your names. You need a way of assigning devices new names. You need ways of looking up, assigning names, and you need a way of locating which devices. Given a name, you need to find a way of locating what device it is. So you now have names. How about the network is incredibly large? There are a zillion different routes across the internet. You have to find a way of delivering your data from one node in the network to the next. So you need to find a path through that graph that goes from your device to the device that you want to talk to. And this protocol is known as the Border Gateway Protocol, or BGP. My entire PhD topic was on 1/500th of BGP and is entirely skipped over in this line. So I feel a bit sad about that. But yes, it's an entire, each of these, to go through the actual workings of these protocols is a course in of itself. So we will just learn roughly what they're responsible for in this. Okay, so you've now got names, and you can find routes through the network to someone with a specific name. The next one is the Transmission Control Protocol, TCP, and this ensures that your data is delivered reliably. So, suppose your message is passing through the network, and you've decided on a route, and one of the computers on that route, one of the servers that you're going through, nodes in the network that you're going through, drops out. The communication link fails, or the node shuts down, then suddenly your message is lost, right? And in theory, you don't know the message has been lost, and the person on the other end doesn't know the message has been lost because they haven't received a message yet, so they don't even know that you were trying to talk to them. So TCP is a protocol of signals and acknowledgements. So whenever you send a message to another computer on the network, they will acknowledge that they've received a message and send that acknowledgement message back to you. So if you send a message and you don't see an acknowledgement, you know, well, either my message has never reached them or their acknowledgement has not reached me, and something's gone wrong. So what do? You resend the message, and you wait until you get a new acknowledgement. And there's a lot of state. Obviously, it's more complicated than that. You need a lot of state to keep track of acknowledgements and packets, because you're not sending one message at a time. You're sending many, many messages. But that's what TCP does. So at a higher level, there's lots of protocols for specific applications. So for example, if you're sending an email, what format should the data that represents an email be in? It should have a header right, which says what the title of the email is and which server, who it's coming from. It should contain the timestamp for time information that it was sent. All this vital stuff that allows you to send one email to another, and for any email client, whether it's Google or UWA, the UWA Microsoft Outlook one, or Hotmail, or any of these, they can all send email to each other because all emails obey a specific data, are all sent in a specific data format. Okay, and then file transfer protocol, FTP, for sending files over the internet. When you're trying to download a file, how do you go about chunking it up, placing it into chunks and things like that? How do you download it onto your computer? And as I say, this is just a small snapshot of the more instantly understandable protocols, intuitively understandable protocols. There's a lot more that go on into actually getting your data to move about the internet. Okay, so briefly going to look at the transmission control protocol and the IP protocol, that in slightly more detail. Again, just to reiterate, like every device on the internet uses this to communicate, and no matter what type of device you connect, if it's internet enabled, then it will use these protocols to communicate. So yes, we talked about TCP and IP briefly, about how TCP handles unreliable delivery. So if you have faulty links, if your links drop packages, drop messages, for example, then TCP will guarantee that the message actually reaches the other end in the end. If there still exists a link. If there still exists a valid path to obviously, if the last path to the computer you want to send information for drops out, then no magic the protocol does is going to allow you to actually deliver messages. But if there's still a path through the internet to that node, then TCP will get your message there intact. Sometimes you don't care about that. For example, if you're sending videos, then you're sending a video to the other person on the other end, a video stream of your face in some video chat. Suppose for some reason your certain frames of the video, the data representing the frames of the video get dropped, then it's not much use often to resend frames of a video that occurred now 10 seconds ago, 5 seconds ago, 10 seconds ago. There's not much point in resending them. Right? So there are protocols as alternative to TCP called UDP, which is the user datagram protocol, that basically gets rid of all the error handling and the guarantee that it means that you no longer have the guarantee that all your message is going to arrive, but as a result of dropping, trying to ensure that all your messages arrive in time and in order is very expensive in terms of compute by internet standards. I mean, when we say expensive in terms of compute, I'm not talking training machine learning models. I'm talking about millisecond latency delays at each node. So when you drop that requirement that you have in order reliable delivery, you can get a much faster, leaner protocol that supports, which is good for things like video, where you really care about real time, or as close to real time as possible. So in all of these, whether you're using UDP or TCP, the stream of bits is split into individual packets. So you send a packet with maybe 1,000 bits, 2,000 bits, 10,000 bits, and you split it up you split your stream of ones and zeros into chunks, and you send them each individually. And in each packet does not have to go the same route through the network as the other packets in the stream. So they really are very independent. And then TCP and UDP are responsible for creating those packets in the first place, and then at the other end of the network, at the other side of the network, reforming those packets into a coherent into the same data stream that you sent. Okay. Cool. Yes. So packets structure. So packets are formed like an onion on the, well, a one-sided onion. Okay, this is a really bad analogy. Okay, an onion which has one side. So on the outside of the onion is the data that is responsible for the lowest level, so the lowest level of the communication stack. So whenever a packet is being sent by a node, it sticks a load of data across a single link in the network. It sticks a load of data on the front of the packet that contains the information, the error correcting information to get it across one link of the network. So a single link of the network. And then let's try this again. This is the first time. Let's try this again. Let's go from the opposite way around. Okay, let's go from the top, which is actually the way I wrote the slides, so I should listen to my past self, much more sensible. Less adrenaline surging through my past self, definitely. The application layer at the top. So in the center of the packet, in the center of the onion, is the information that is the information that you actually want to send. It's the email information. It's the text of your email, for example. And then around that, the text of your email, they will then append the application layer information. So that is, for example, the time and date of the email, the server it was sent from, the address, etc. So all that information gets pre-pended to the front of your packet. And that's the application layer. The transport layer, you then, when you're sending it, you then take that information and then you want to send it to another computer. So the transport layer is the TCP protocol, and it splits it up into chunks, and it appends more information about, okay, what is the address that you're trying to send this packet to, and which route it should take, for example. The internet layer is responsible for transmitting the individual packet. So we split up packets into individual ones. The internet layer is responsible for transmitting a single packet that contains routing information. And then the network access layer is how a single packet is transmitted, is the information that's necessary to transmit a single packet across one individual link of the network. So you can think of it 4 layers with 4 different levels of responsibility. The application layer is what information is actually needed for the content, to make sense of the content of a message. The transport layer is for getting a stream of packets all the way across the network. The internet layer is for getting a single packet all the way across the network, and the network access layer is for getting a single packet across one link of the network. And at each stage, you can each stage as we go down here doesn't need to know what information is attached at the previous layer. So if you're the network access layer, then you don't care about what the internet layer or the transport layer or the application layer was doing. You just stick the information that you need to transport it across a single link onto the outside of the packet and send it across the link. Okay, so that's how you send messages across. How do we organize information how do we organize the sending and receiving of information between different nodes? When do we agree? Who sends information to whom, basically? So most of the internet, not entirely, is based off a client-server relationship, where one server holds all the data to do with a particular whatever application you're interested in looking at, or yes, any sort of central source of data that people want to access, and the clients are the people who want to access that information. And the server's address is known, is widely published on the internet, so everyone knows which server they should be going to get the information. and the client sends a request to the server via some protocol, whether it's an email protocol or SSTMT protocol or where you want to download a file. And then the server, upon receiving that request, the server then transmits the information back to the client. What are the advantages of this model? Well, multiple clients can use a single server. So you can have an unlimited number of devices, all which access the same content, well, within reason, an unlimited number of devices, all which access the same content from a single computer in the network. And new clients can join whenever they want. They don't have to be registered with the server in advance because the client is the one that is initiating the exchange of information. And furthermore, we have a single authoritative source of information. So there's only one true copy, and everyone knows where that one true copy of information is. People may request local copies of it, but people know that that server is really the one which has them, which is the source of authority. There obviously are lots of disadvantages. This kind of goes across against the notion of robustness that we talked about right at the start of the lecture. I mean, if a server goes down, okay, it's not going to crash the internet, but it means that this particular application is not going to work anymore because the server has disappeared. So when clients request, their requests are going to be ignored and they're not going to receive any information back. And also, when I said unlimited, I definitely didn't mean unlimited, because if in practice you have too many clients all requesting information at exactly the same time, then the server is not going to be able to answer the requests fast enough to send the data back to all the clients that are requesting it. And your response times drop, and eventually it will start just dropping requests. It will start ignoring requests from the clients. So, well, obviously things like Facebook or Google, they don't have one server out there, right? Serving they have lots of servers, all that serve the same information. So the model is not fundamentally different. It's still a client-server architecture. You as a client, anyone can log on, can go to Google and start requesting searches, or Facebook and start requesting messages. However, there are multiple servers scattered around the world. And obviously, you then have a very hard computer science problem of trying to ensure consistency between the information. On all your different servers, you want the same information on all the servers. And if information is updated on one server, you want that change to propagate to all the other servers that exist in the network. As an aside, the trend at the moment is actually to push these servers out as far as possible to the edge of the internet, so as close to users' devices as possible in order to minimize the latency. There has been much research shown that us fickle consumers, even a third of a second delay on a web page loading is enough to make us think, oh, this website's slow, maybe I should try and investigate having an alternative. So the current trend is for content distribution networks, which are basically entire companies that exist to create copies of your data for you as a company, your company's data, to copy it to as many servers as possible in as diverse locations as possible. So the distance from every client to their nearest server is as small as possible. So the trend really is for servers to proliferate. There are lots, and every major company, internet company, will have many, many, many servers in as geographically diverse locations as possible in order to minimize the latency. Can anyone name an alternative model apart from client-server model for communication? Peer-to-peer? Yep, peer-to-peer. So that's the main one, where everyone is equal in the network, and you broadcast what information you have available, and then any two computers can, and then you can initiate there's no privileged copy of any information. You just say, I happen to have this information, would you like it? And then other people say, yes, I would like that information, you initiate a transfer between two computers. So it's much less hierarchical. But obviously it's more expensive to maintain because you don't know. You don't know necessarily whether other people will have that information available, and you need to keep lots of redundant copies because no one is centrally responsible for maintaining that information. So if all the people with that information drop off, then you can't find it again. Okay, so this is how the internet functions and whistle-stop tour of the protocols and the technology that is underneath it. We're now going to look a little bit at the applications that have been built on the internet, both historical and current ones. The very earliest software, for example, that was built on the internet was bulletin board systems. And this was in late 1970s, early 1980s. And there's some exceedingly funky retro graphics. People could log on to these bulletin boards. They could exchange messages through a version of email, or they could post public messages. So you'd put a message to the server, and then when everyone else logged onto the server, they could request all the messages that people had posted publicly, and the server would send them a list of messages. You could upload and download their server stored software, so you could upload and download software, and even basic online games, text-based online games. Sorry? Yes, that sort of thing, exactly. Correspondence chess or very, very basic stuff. These were accessed, as someone said earlier, these were accessed by your modem or phone line. So if you had logged on to a bulletin board, you could not make a call at the same time, and no one could call you, which was irritating. I'm sure some people remember being told in this room, some people remember being told, you've got to get off the internet because the phone line doesn't, parents want to make a call. Still early 1990s, that was still the case. And it was a precursor to the World Wide Web today. But it was pretty amazing what they could do with even the very limited technology and the very slow networks. Usenet was another one, which was, again, built by graduate students at Duke University. Anyone know where Duke University is? I have to confess I don't. Okay, cool. At a place called Duke University. Unlike bulletin board systems, where there was a single server, these were a distributed network of servers. So more approaching the notion of servers that perhaps we have today. And there were large groups of forums called news groups, which, despite their name, didn't just serve up news. They actually served up user posts. And you could have threads, just like on social media today, and you could join communities and lead communities, and communities formed around special interests. And this was really the precursor to internet forums that we know today. And again, yes, very retro text-based interfaces, so nothing fancy, no graphics. You could download individual images, sure, from another computer, but the idea of displaying images as part of a user interface was not possible at this point in time. Everything was text-based. Okay, so the killer application that came along was the World Wide Web. Now, it's really commonly confused, the difference between the internet and the World Wide Web. The internet is the physical network that that is responsible for transmitting information to and from computers. The World Wide Web is really an application that is built on top of the network that is responsible. It's another set of protocols that is responsible for transferring information around the internet in a way that is incredibly easy to navigate and is human-friendly. So, in the early internet, in all these networks prior to the World Wide Web, widely used, lots of users, but information was incredibly difficult to access. You needed to know the IP address. Remember the IP protocol, which assigned a unique name to every computer? You need to know the IP address of the computer you wanted to connect to. And an IP address is a 12-digit number, basically, and you needed to know the 12-digit number for the computer that you wanted to access. So, you could not type www.google.com and go to Google. There was no human-friendly names. You had to know these numbers. And there was no standardized way of actually displaying information that you got back from a server. You had to write your own custom way of displaying the information you got back for every single application that you wrote. And in 1991, does anyone know where I'm not sure why I put this in question marks, I guess, quiz time. Does anyone know which organization the World Wide Web was invented at? Yeah. Yes, the LHC, so CERN, it was in Switzerland. It was actually invented by a bunch of physicists who were building the Large Hadron Collider in Switzerland, and it was a truly international project. There were scientists from all over the world collaborating, and they were generating a lot of data, and they really wanted a better way of sharing the information with their collaborators around the world. Yes, and it was invented by a researcher at CERN called Tim Berners-Lee, and basically they came up with the idea of domain names, so having a human-readable name for a server. So think google.com or facebook.com. So they came up with the concept of the URLs, which is this string of text, which has a specific format, which we will talk about in the next slide. And then there is a clever system. Again, it's a protocol. You send the URL off to a server, and a special server on the internet will tell you, okay, this URL resolves to this IP address. And then using that IP address, you can then go and communicate. Your computer can then automatically go and communicate with the other computer without you as the user ever having to know what the IP address is. And in particular, it didn't just have the concept of URLs, it also had the concept of a web browser, which was a program that displayed information received from servers in a standardized way, assuming that the information sent from servers was also in a standardized format, i.e. obeyed a certain protocol. And this is where, when I put these slides together, the first website was online a week ago. I hope it's still online now. Yes? So this was the first ever website created. It is very basic, but as you can see, it's got all the things like hyperlinks that allow you to navigate between pages, and it has a list of CERN products, which were made using the World Wide Web more easy to navigate. And indeed, you can see that the URL is still hosted by CERN. For historical reasons, I assume. I really doubt they're still using this particular web page. I really wish I knew how to maximize this without going in and out again. Okay. Right. So we saw it on that web page there, but one of the crucial innovations. Do I have it? Yeah, one of the crucial innovations was the idea of the hyperlink, so the blue text. The idea that when you wanted to go to a different piece of information, you didn't have to resend the request. You didn't have to go through the entire procedure again as a user to find the right server. You could just click or follow a link on the page, and it would take you to the next piece of information. And this was really turning information on the internet into a network itself. A network was being formed between the different pieces of information on the internet, and you could, like you were navigating the physical, like all your messages were navigating the physical infrastructure, the internet underneath to get you this information, you could also quickly follow links in this graph of information that was available on the internet. And the browser, web browsers, enabled you to do this. So they rendered all this information in a uniform way. The first ever web browser was written shortly after the publication of World Wide Web and at the University of Illinois, and it was called the Mosaic web browser, and it was kind of, I think the style is not, I mean, yes, it's retro, but I think they did a fairly good job at stylistic design of the thing. I mean, it holds up even now, I think. Again, written by students. I think that the underlying message of this first lecture is actually that students were, PhD students and grad students were actually the underlying force behind driving much of this technology. Yeah.
Search functions or just like categories?
It absolutely did not have search functionality. And indeed, the search functionality took surprisingly, it took 7 or 8 years before a really good way of searching came along. As you can imagine, you have an arbitrary network of information out there, none of which is indexed in a computer reader form. It's all text, and you somehow have to find arbitrary documents in that network. It's quite a hard computational problem. And yes, people came up with better and better solutions before the PageRank algorithm came along, published by early iterations of Google. And that was how Google really came into being, was search, was coming up with a good way of searching this web of information. Yes, well, obviously, the idea that you didn't have to know your individual IP address and you didn't have to work out how to render the information yourself proved a massive hit with people. Like suddenly the uptake of the internet, I mean, the uptake of the internet was doubling every year. It suddenly went from doubling every year to, deeply exponential. There were increasing thousands of percent in the number of users. And this really was the killer application. So I guess the important thing to take away from this is the difference between the World Wide Web and the internet per se. I mean, the World Wide Web is built on top of the physical network that is the internet. And it is really an advanced, a very, very distributed application in a way. Okay, so client-server architectures in the web. The idea, how do you get a web page from a server? Well, you communicate via an agreed protocol. We should be counting the number of times that I say protocol in this lecture. It's going to be a lot. This is usually the hypertext transfer protocol, or more usually nowadays a secure hypertext transfer protocol with added cryptography added in. And what happens is that the user says, okay, I would like to view this web page through the browser. And they type in the URL and in a program running locally on their computer, and the browser says the browser is now the client. Rather than like you specifically, the browser acts as the client and locates the correct server. It resolves the URL into an IP address and then communicates the request to the server. And the server retrieves the web page from its local file system and transmits the files that it has at that particular web page back to the browser. And the browser then receives the files, and it's usually in text format, so it's not, well, it is binary bits at the bottom of it, but it encodes human readable text in containing instructions for HTML and CSS and JavaScript and that sort of stuff. All the stuff that we're going to cover in later lectures that tells the browser how to go about displaying that information and what style and how the user should be able to interact with a web page. And then the browser can use this information to display, to use the HTML and all the text received back from the server to render it render the information on the screen in a way that you can interact with in your browser. And it's a cool picture. I can't exactly remember what I was planning to talk about it. I guess the idea that servers became ever more important under this model, and it wasn't enough under the idea that you'd have hundreds of millions of people hitting your website, requesting the same content, meant that really under the World Wide Web model, an individual can't. A single computer isn't sufficient as a server anymore. When you have millions of people all requesting exactly the same content, you need to scale up to data centers with hundreds of servers, thousands of servers, all capable of delivering exactly the same information to many of your users. So, URLs. URLs are actually URLs are dying out as well. I mean, the search is, when I say dying out, started dying out 15 years ago. When search became better and better, you no longer have to use URLs. I mean, URLs were a step up, massive step up over IP addresses, right? Before you had to remember arbitrary numbers. Now you can remember meaningful strings that are memorable. On the other hand, you still, oh, this is where I have to remember to plug in. Yank. Okay. Yes. URLs are meaningful, but they're still hard to remember, right? I mean, okay, quick show of hands. Who has typed in a URL into a web browser in the last month? Okay, maybe 15%. Okay, I guess that definitely qualifies as dying out. Nonetheless, this is still the technology on which the web runs underneath. Google will still deliver you, when you click on a link on Google or any other search engine, it will still use the URL to resolve the IP address. So it's still used, it's not visible to users anymore, but when you yourself are designing websites, URLs still form a crucial part of the underlying technology. So you still really have to understand how URLs work and what their format is in order to be able to build a functional website. So you can split the URL up into chunks. The first part is what protocol you are expecting to receive the content from the server in. So are you trying to get a web page, in which case you'd probably use HTTP? Are you expecting to receive back a file, in which case you'd use the file transfer protocol? Are you do you want a secure connection where other people cannot eavesdrop on the information you're sending to that or receiving back from that web page, from that server, in which case you'd use HTTPS. There's then a colon and double slash, and then the next part is the domain name. So this is www for World Wide Web, and then a sequence of strings that are divided by full stops that actually determine I want to say the physical computer, but it no longer maps to a single server because there's multiple servers, but it maps to the logically the set of devices that you want to, a set of indistinguishable servers that you want to receive the information from. So it's a name that maps to the set of servers that has that information that you're interested in. And that gets mapped to an IP address. And then different servers may be running the same server, same set of servers. Maybe it's supporting many different applications or many different at the same time. So servers have what are known as ports, which is a number between 0 and 2 to the 20, 2 to the something, that says, okay, what application am I interested in? What service am I interested in obtaining from this web server? The default port is 80, and different ports usually have different semantics. So different ports will be reserved for, firewall traffic, or for server traffic, or for other things. And it's easily lookable up online which ports you should be using for when you're designing your application, which ports you should be communicating. You'll have your server communicate over. You then have a part of URL, which is the path to the file. So this is referencing on that machine. This is talking about their file system. So in their file system, which file are you interested in retrieving? Now, obviously, this sounds, to the security-minded people out there, this sounds a bit scary, that you can just that you have to know what the file system of the server looks like on the other end, and B, that in theory, you can just request arbitrary files off it. You absolutely cannot request arbitrary files off it, and servers have security mechanisms to ensure that, like, when you request an arbitrary file, you're not going to get an arbitrary file back. It will only return files that you are authorized to have, and it's not just going to give up files to anyone. And indeed, I'm sure many of the security courses will have been talking about bugs where vulnerabilities in server architectures where they do allow you to return arbitrary files on the server, and that is a big problem. The file is not, there's no particular, it doesn't have to be any particular type of file in theory. It's often, in practice, it's dictated by the protocol, but many protocols will support, file transfer protocol, for example, will support you downloading any type of file. So it doesn't have to be an HTML file. It could be PHP code, it could be a text file, it could be a PDF, whatever. It's agnostic. Sometimes you will want to tell the server will want to know information from you about what it, and they will use that information from you to customize the content that you have returned. So, for example, you can send information. For example, you might have a form on your web page where you enter your name and your date of birth, etc., and those will get passed to in the URL. May get passed in the URL as parameters, which the server can use to customize the content that is returned. And these are key value pairs. So on the left-hand side is the name of the left-hand side of the equal sign is the name of the parameter, which is again dictated by is known to the server in advance, so that's fixed. And then on the right-hand side is whatever the value of a parameter that is being sent by you/your browser. So on the right-hand side is your information, and the left-hand side is the name. So it's really like a dictionary in Python, if you think about it, if you want to think about it like that way. Finally, there is the fragment part of the URL, and this is used to say where you want to go within that file. So when you're using HTTP in particular, this will link to a particular point in the page, so that if you go to that fragment, and it's a unique ID that is linked in the information that's returned, and when you enter that ID, it will automatically auto-navigate you to that point in the web page. So you can have more fine-grained control over where you want to go. You don't just want to, you still have to get often you still have to get the entire content, but you don't need to start at the beginning. It can take you to an arbitrary point in that content. Apart from the URL that you see in your web browser and that you can type in, there are also hidden parts, which include the name of the browser that's being sent, that's sending the information, and various metadata about the browser. So different browsers may have different capabilities, for example, so the server may want to customize the information that's being sent to optimize it for your browser or for your device. And then there are also infamous cookies, which is information that websites store about you and your device from previous visits that are stored in your browser, and that this information is also sent to the server so that the server may know, I have seen this customer before, they really liked buying internet-enabled water bottles. Let's customize the adverts to show them more internet-enabled pencil cases, because that's clearly what they're interested in. So that also gets attached to the information that is sent to the server via the URL, the request. And yes, URL stands for Uniform Resource Locator. And uniform because it's really quite agnostic as to what you're retrieving from the server. So the idea is that that you can request anything from the server using this. Yeah.
Are the hidden parts sent alongside the URL, or is it like different for when it gets sent to the server?
Originally, they were definitely part of the URL. I am unsure about exactly what happens in modern web browsers and whether they're still included as part of the URL or whether they're included as part of the data package that is sent to the server. I would have to get back to you on that one. Sash, advise you to go look it up on Wikipedia Online. It was certainly originally the URL had everything, but now the hidden parts cookies can get very, very large. So I'm yes, unsure is the answer. I apologize. Okay, so what's the World Wide Web like today? So as we've made clear, the World Wide Web and the internet are not the same things. There are many services available on the internet that do not follow that are not accessible by the World Wide Web simply because they don't follow they don't use URLs and they don't use they don't use URLs they don't provide URLs to be addressed with, and they don't serve up HTML or things like that. So the World Wide Web is just a part of the information that's available on the internet, and if you want to use other parts of it, if you want to access the rest of the information, then you have to fall back on other mechanisms to find that information and locate it. And this is kind of what's known as the dark web, right? It's information where it's not indexable by the search engines because it's not connected to the graph of information out there. So it's only a fragment. It is a very unique engineering environment in that most big infrastructure projects will be owned by a very small subset of owners. And therefore, if you want to get something done or you want to make a change to how the project is set up, then you kind of know who to go to. The World Wide Web is not like that. There's many different standards committees out there that if you want to change something, you can go and talk to them, and maybe in 6 years' time, 7 years' time, after many heated arguments and discussions, you might manage to make a small tweak to a part of how it works if you're lucky. More likely they're gonna go no, because what you propose will degrade the experience of, even if it improves the experience of 2 billion people out there, it's still going to degrade the experience of 500 million people out there. So the World Wide Web is very slow to change. Fundamental technologies that underlie it are very slow to change, even if the things built with it can change very rapidly. The ownership is actually quite obscure as well in terms of, okay, there are these public standard bodies that dictate it, but who exactly owns which server and where your information is being sent is really not clear to you as a user in your web browser. And you have very little, as a user, you have very little, by default, you have very little control over, once you start typing information in your web browser, where that information is going. And there are various initiatives in the EU in particular about trying to give users more control back over where the data is, but fundamentally you don't know who owns all the infrastructure that you're using whenever you use the web. It is arguably one of the most impressive pieces of, if not the most impressive piece of infrastructure ever built by humanity. The sheer number of people hours that have been spent creating content for the World Wide Web dwarfs pretty much anything else in the world, and certainly couldn't come up with anything off the top of my head. Okay, we've talked about the standards that go into like URLs, that go into delivering web pages, but there are above that layer, there's tens or hundreds of more standards that dictate how web pages should be laid out and how they should be accessible, so that screen readers can read them for people with different abilities and or disabilities, and they define what's the best practice for laying out various common components that make up a web page, like login boxes or things like that. So there's really, it's standards and protocols all the way down. And yes, finally, okay, way out of order. As search has come to dominate the World Wide Web, URLs are becoming less relevant to users in particular. And there's now the browsers in the mid-2000s and early 2010, the number of browsers was expanding. So there were many, many different browsers that you could access the World Wide Web via. Now it is kind of concentrating again, and Google Chrome in particular has a huge market share, which allows them much more power in setting standards in the web, which is arguably, well, depends on your view, arguably a good thing or a bad thing. So I guess brief talk about the World Wide Web tomorrow, and yes, I realize the date says 2021 on the right, which was arguably not tomorrow. In the beginning, in 1990, when the World Wide Web was just getting started, in the first 10 years of its existence, it was a very static thing. It provided this network of information that you could navigate and you could go through, you could follow hyperlinks to navigate between, and you didn't really interact with it. You didn't create your own content. You were a consumer of content only. And it was really the technology that was underlying this was all about focusing on how to deliver that information to you. And there was very little static communication, and you as a consumer really didn't have to implement as a browser, you didn't have to implement very many advanced algorithms or things like that on your end, because all you had to do was render the web page. That was your job as a browser. And there are lots of, as examples of web pages and applications, things like news organization. For news organizations, this was fantastic, right? They could publish information, and millions of people could instantly get access to the information they published. But in the early 2000s, it quickly started to change, because actually companies realized, why are we going to all the effort to create all this content on the World Wide Web? Wouldn't it be way cheaper to get users to create their own content for other users? And we just provide the mechanism for getting that, allowing users to share that information. So this is what's known as the social web. Suddenly you could start entering information on web pages, and that information would be stored on servers in the cloud, and then other users could go and look that information up. So it's dynamic content, and suddenly you could start to collaborate over the web, and they started building some quite impressive applications. Social media is the obvious one, the rise of Facebook and various other social applications. Facebook wasn't the first, but it was certainly the one that reached dominance, reached critical mass first. There were blogging, content hosting, so you could upload images to image sharing websites and anyone could look at your images. Podcasts, so you could upload your own audio files and people could download and listen to them. And this is when mobile phones as well started to take off. So the key technology that kind of brought this to everyone is that you could suddenly access the web via your mobile phone. And you could actually start to build programs on top of the web. So programs that compute on your side, on the client side, that actually computed the data that the users did serious heavy-duty computations on your local computer before sending information backwards and forwards to the server. It was also the start of big data, because before there were very few people publishing content, only companies were publishing content on the web. So although there were tens of thousands, millions of web pages, now there were billions and billions of web pages and blogs and content, that suddenly the scale of the data on the internet, now that anyone could start creating their own data, the scale absolutely exploded. And with that, people started trying to work out, well, okay, we've got all this information, what can we do with it with AI? And even much later on, blockchain came along, and it's another example of a application that's built on top of the web. What were the challenges with this? Well, obviously, access to information now that users are publishing information. How do you limit where your information goes and who gets to access it now that you're just shooting this information off to some server on the web? Malware started to become a serious problem because now that you're actually downloading applications that you run on the web, those applications can be malicious, and they can start, and it's an excellent vector for getting those applications onto your computer. And then things like data leaks and data integrity, which I guess is the same as data ownership, really. Well, I guess they're unintentional. Whereas data ownership questions are, I've sent my information to that company. Is that company deliberately sharing it with people I don't want? I guess this is accidental sharing, where malicious actors get access to your data. And this is where many of the huge internet companies that have come to dominate today grew up in. Amazon, Apple, Facebook/Meta, Microsoft, Twitter, Google, TikTok, all these companies really achieved their dominance through this notion of an interactive web, where users could both interact and could both generate and receive information. Which leads us on to the future of the web, which is Web 3.0, which is arguably still in development, which is an intelligent and decentralized web, which is really, you're not navigating, and ChatGPT and large language models like that are really the forefront of this. Whereas before, in Web 2.0, you were still navigating to information was located on a single page on the internet. And yes, it was super easy to find those pages, but you were still going to a particular page. In the semantic web, in theory, the idea is that web should be able to synthesize that information from many different sources across the web and bring you only the information that you're interested in. So ChatGPT is an excellent example of this, right? It's learned from the entire web, and then you ask it a query, and it will produce some copy of varying accuracy from information that it has seen across the web. And this is really just getting started. And it's some of the uses of this. You can well, yes, there's and I guess so another part of the semantic web, I guess, is the notion of decentralization. That once again, the things like cryptocurrency and blockchain and things like that are trying to make the web more democratic, so less centralized. The idea is that maybe we won't have that access to the web gate-kept by these massive corporations, that maybe the web will become more decentralized again. Whether or not that's happening in practice is a bit more dubious. But these technologies have really enabled a lot of really cool applications. The challenges are in some ways similar, and in some ways there's a few new ones. Personal data collection is still a huge problem. Now your personal data is even more valuable to companies than it was 10 years ago with the advent of AI because they can get far more insights out of it. Cybercrime is becoming more sophisticated with the information that you put up on the World Wide Web, whether it is your voice or your videos of you or even just text. AIs are now capable of creating, just from that really innocuous information, they're capable of creating very sophisticated clones of you as an individual, which can be used for whatever purpose they want. And finally, there's the problem of AI bias, which is becoming also a huge issue as these AI systems get deployed throughout the web, which I'm sure people have all heard and read lots about in other courses and on the news. Big topics in the news today. I think Microsoft's, I've forgotten the name, it used to be called Bard, it's not called Bard anymore. Gemini, yes, has got in trouble for they tried to correct the bias of being politically correct, and they went way too far, and it now generates lots of deeply historically inaccurate political correctness statements. And yes, examples of technology is ChatGPT. Alexa from Amazon was a very good early example of what the semantic web hoped to be. You had a single device in your room that you could ask questions to, and it would retrieve information from the internet and deliver it to you in a bespoke fashion through the medium of voice. A slightly more left field one, I'm not sure how many people have used Wolfram Alpha. Oh, again, less than I would have thought. Okay, Wolfram Alpha is a kind of computation engine which can do very advanced mathematics, but it is also plugged into the World Wide Web, so you can ask it how many Earths fit inside the sun, and it will go away and it finds out how much the sun weighs and how much the Earth weighs, and then it goes away and performs that computation for you. So again, it's a way of synthesizing new information from existing content on the web. And that's really what Web 3.0 is about. Okay, and that is the end of lecture 1. I guess everyone will be happy that we finished 20 minutes early. I apologize. I really did mean to have a 5-minute break in the middle of it. Confession time. This is the first ever lecture I've ever given, so I am still... Thank you. I am still a little bit nervous. I'm hoping it will get better as the course progresses. There will be breaks. If in future lectures, I'm sorry, there is some more information about labs and stuff, so not quite going yet. In future lectures, if I forget about breaks, please someone stick their hand up and say. Labs, on Friday, we will be at 9 a.m. I think we're back here. I will be trying to do some live coding, talking about how to set up your development environment. It would be great if everyone could bring their laptops, and if they could go through the instructions. Maybe it might be worth going through the instructions for a first lab that is available on the LMS under Labs, which will set up your development environment and make sure that you're ready to go so you can follow along during the course. Okay, cool. Thank you, everyone. Oh, there is a workshop of this Friday, which will be out setting up the, Hi.
I just want to say you're talking very well. Like casual, but also very focused.
Good. I'm glad. Thank you very much. Oh, that's nice to hear. Yeah.
So actually on Friday I'm having a problem. I am having a clash with another lecture.
Okay.
And that's also only on Friday.
Okay.
There is no other slot for that.
So the labs will be filmed online, will be available on the lecture recording system online. So after the lab, you will be able to come along. Sorry, workshop. Okay, terminology. After the workshop, you'll be able to see it online. The labs, you will then be able to go and talk to facilitators individually to clear up any bits that you...
Okay, so I can only attend like one hour, I think.
Okay, that's absolutely fine.
Because they have only one, there is no other lectures also, there is only workshop for that.
Okay, Yep. Yeah, that's absolutely fine. There is only one. There's only one, but it will be viewable. It will be viewable online, and you will be able to. You'll still get personalized support in whichever lab. Yeah. No worries. Hey.
I don't quite get, like, I get how Web 2.0 is like a great
Yeah.
complete reinvention of one, and then I feel like 3 is just an addition to 2, where it's not, because like something can be interactive, something that's interactive can't be static, and something that's intelligent can be interactive.
Oh, but I mean, interactive is a generalization of something being static, right? You can have, I mean, the technology, just because you have an interactive page doesn't mean that with the same technology you can't deliver a static page.
Yes, but a single
it's-
thing can't be static.
I guess
and
it's the
interactive.
technology that enables it. So the
Okay.
technology, at the start, the technology only enabled static pages.
I see.
And then the technology enabled both static and dynamic pages.
I
And
see.
now the technology
So
enables
Web
both synchronous
3.0 isn't necessarily getting everything to Web 3.0 style. It's
No,
getting
no.
every page.
Well, it's
enabled
not
to-
every page, it's just building the capability on top.
Yeah, I
And
see.
it's the dominant mode of interaction,
Okay.
I guess.
All right. Thank you.
I would like to know whether I can choose a group of 2 instead of a group of 4, or it has to be a group of 4
It has to be a group of 4, I'm really sorry.
because of the agile thing.
Because, yes, so I think you definitely learn more, I think, in terms of collaborative, and yes, just because of numbers this year. If for some reason you have a really, really good reason for why you want to be in a smaller group, there may be some groups of 3 left over. So if you have a convincing reason why you want to be in a smaller group, I can try and add you to a group of 3, but maybe a group of 3 left over, which you can add to.
Yes, thank you.
Hi, I just want to try whether the workshop must be taken participation.
Must be participation in what sense?
Join the workshop because it was casual with another unit at the time.
So the workshop, so the workshop is again me talking at front and hopefully more interaction with people. It is recorded, both the lectures and the workshop will be available online afterwards, so if you have another clash, you can watch it back online. And then the labs are your chance to go and actually talk through this stuff with an individual, with one of the facilitators who will help you if you've got problems with it. So yeah, you don't have to turn up to the... Hi. Yep.
What's the difference between the web app and the actual like a mobile phone?
What's the difference between the web and
Mobile application?
a mobile application?
Is this?
Okay, so yes, so they are different.
Yeah.
So the web page, although the line is blurring, so the web pages are all rendered via HTML and CSS and all these standard technologies. Mobile apps usually don't run through a web browser.
Yeah.
So they are much more on the old style of internet, where they receive the information in a custom format dictated by the server, whichever server they're communicating with, and then they display it in a completely custom manner. Now, as in they don't use HTML, they don't necessarily have to use HTML or CSS.
Yeah.
They use a native, just like any other application on the computer does. They use native GUI components to build the interface on top of it. Now the line is blurring slightly because nowadays you can take web applications and you can turn them into apps almost instantly, and you can take mobile applications and you can sometimes turn them into web applications using different technology. But yeah, does that make sense?
Maybe I need to dig in.
Maybe it'll get more clear, I think, once we start digging into HTML and CSS and how the pages are actually.
Oh, I think I didn't realize web is also kind of like an application.
Yes. So when we say applications on the web, I mean, we say, what I meant by that is things like Facebook or things like, a set of web pages that have a coherent purpose that you can click through. I mean, you can now use Microsoft Office on the web, right? I mean, it's an application on the web. It's not an application on the desktop sense. You're clicking and running it. But
True.
Yeah.
Okay.
Programs maybe is a better.
Okay.
Yeah.
And just for the groups,
Yep.
should we just find our group mate outside?
ourselves, and if we cannot, then like it's like
So there'll be an
randomly-
option to put down that I'm looking for a group,
Yeah.
and you will then be randomly assigned to people.
Okay, sure.
So you can, I wouldn't, well, yes. If you find a group of people who want to build
Yeah.
the same thing,
Yeah.
fantastic.
Yeah.
Uh,
if you-
submit as a group, but if you don't have
Yeah.
strong ideas or you don't have a group of people, then you'll be assigned a group.
Okay. Yeah. And when will the group assignments start?
Uh,
Project?
It will, well, all the way through the labs, you'll start be building stuff that like will help towards it. The groups will be formalized at the start of week 3 around,
Okay.
and then you won't have enough knowledge right then to like
Yeah.
go away and build it all like
Yeah.
at that point.
Yeah.
But like you'll then be working on it throughout the rest of the course.
So, like the project will be announced on
Yes.
LMS. Like,
Yeah. So and I will cover it in lectures as well. Yes.
and when will
At this around about the same time as groups come out.
week
Yeah.
3 or
Week
week
3.
4?
We get there.
Okay.
Yeah.
Yeah, that's my question.
Okay.
Thank you.
Cool. Hi.
just have one question because according to the timetable, there is another workshop on Friday,
Yes.
but I'm not sure what the content of the workshop is. It's like the lecture today.
Okay. So yes. So today, Wednesdays will be the theory,
Yeah.
and then the workshops on Friday will be actually putting it into practice. So actually building a web page using will be me trying to do it live.
Okay, so it is like a lecture today, and it will be have a lecture recording, right?
Yes. So it will have the Fridays will have a lecture recording
Yeah.
as well that you can see online. Yeah.
Because I might have a really big problem. The
Clashes.
workshop on Friday is complex
Yeah.
to another course
That's absolutely
workshop,
fine.
and that
That's pretty
requires
common. Yeah.
in-person attendance.
Yep.
So I can't be there. I need
It will
to,
be online,
Okay.
and then the labs will provide an opportunity for you to
Okay,
interact.
thank you so much. Another question.
Yeah.
Do we use Python to write Python and HTML and CSS has to write a website to build a website?
Sorry, what was the first one?
Web page.
Web-
Python?
Python.
Yeah, use Python or Java.
Wasm.
Python.
Oh, Python.
Yeah.
Ah, right. Okay. So we will go through, but the web pages will be a mix of the server will be in Python,
Yeah.
and then JavaScript will be the front end language.
Okay.
So 2 different languages. So hopefully you've done Python as a prerequisite. So yeah.
Okay, thank you so much.
Yes.
Are we using Python, CSS, JavaScript, and
JavaScript and jQuery library and some libraries in JavaScript as well.
okay.
Yeah. Okay. Cool. Hi.
Hello, 3 questions.
Yes.
There is, in CAS, there's a lab for 8 o'clock, 8
Yep.
a.m. on Thursday, which did not appear in your slides. And
Yes, that's
last year around this time I did computer networks,
Yep.
and I was in a lab that was not supposed to be there as in CAS.
Okay.
But there were no lab attendants. The
There
teacher
is-
did not know it was
There is a lab
in the
attendant.
system.
There is a lab attendant there. That session was added this morning.
Okay.
I forgot to update that, but I will post a reminder on them. Yeah.
Good.
Sorry, just give me.
2.
Can I just have 1 second to write that down? Sorry.
Sorry.
Okay, so test date was a huge watch. Talk about extra lab date. Okay, yeah, go.
What, second, can postgraduates and undergraduates be in the same group? Because I'm an undergraduate and I know a lot of postgraduates.
No, I should have, that will become clear when I talk about more of the project. Unfortunately, I should mention that next time as well.
They
Yeah.
have a higher project standard.
They have, the marking scheme is the same. There's not, I don't think there's a higher project standard, but for various logistical and administrative reasons, they need to be kept separate. I'm sorry.
Okay.
Sorry. Just the way, if you're doing SITS 33304,
Yeah, that's fine.
then you have to do it with SITS 3304.
Most of the people I know are in the 5s.
I'm sorry about that. If I could make it possible, I would, but it's an
Yeah.
administrative requirement that they do.
Fair enough.
Final question?
Yeah, ideally, how soon would you upload lecture slides before a lecture?
I would hope a couple of days before. Today was a bit slow.
Because I would normally print the lecture slides and then take notes on them.
Okay.
Eh, Yeah, but
I
if
will.
that's not possible, then I just need to relearn to write quickly.
Okay.
Because after high school, everything was mostly typing, and after 2 years, I just could not write
Okay.
very fast anymore.
Okay. I will do my best. Do my utmost best to get them out earlier.
Okay. Thank you.
No worries.
Thank you very much.
Hi, I'm
welcome.
Zephyr. Nice to meet you.
Hi, nice to meet you.
Thank you so much for the lecture. I didn't realize it's your first one. You did such a great job. I was wondering if you can explain, just because I'm trying to prioritize what information to review from this set of slides, and also to contextualize it in terms of practicality.
Yep.
So I just wanted for your personal kind of opinion on the relevance of TCP/IP layers for communication over the internet in terms of how is this knowledge specifically implemented? Can you give me in your code, like for example? So if you could give me examples.
So the reason why we don't go into it deeply is that because you will not need to interact with TCP or IP.
I see.
The libraries that we will use to implement the servers will abstract over that. It's just purely for, I mean,
Just background knowledge.
background knowledge about how these things actually work. I mean, their existence will be examinable in some sense,
Yeah.
and their purpose will be examinable,
Yeah.
but you won't have to know the implementation.
Sounds good. And in terms of the final exam,
Yep.
so we would have to still understand all of these theoretic concepts in addition to the practical application of how to build websites and things like that.
Yes, so indeed. So the content, in some sense, there's it's two courses really. One is the theory of
Yeah.
web development, and one is the practical one. The
Interesting.
practical part will be assessed by the group project, where you actually build something, and the theoretical part will be